Now, actually, you know what, you can't move that little square at the top, because it's just stubborn. However, we can move this. Yes, come on, lady. All right, and then here, and then here. Yes?
Yes.
All right, and now we have, this is the column that you're changing. Okay? And we
I don't
can,
know how I feel about just changing it to the completely new one, because we got,
okay, so here's now the copy. This is the copy.
This is not
Okay, this is
consistent.
a new copy. All right, so now put the numbers in for 250 and 350.
250 was the one we measured the first time, and it was correct. Like, through here. We
Okay.
wanted 350 and 450.
Yeah, but if you go up to 400, if you make this guy 600 right here for 350, that's screwing everything else up.
It's not consistent.
No, it isn't. So if you want to do it again, I've copied it for you to do the values.
So do we want to do it again?
I don't know, it depends on whether you want a 19% error. You don't get grade on the error, if you would like to see if you can get the error better.
Okay.
Okay?
Try.
Okay.
So for 250 we have 450. And then I can just type right in?
Yep,
Sweet.
and it will immediately change.
Okay. And then for, oh, how can we do this? You're a tech whiz. 570. And does the percent error change now too?
Well, the slope isn't changing, we'll have to put the slope back in.
Oh, okay.
Okay, so now we want what, 450?
Yeah, we want to look at 450.
Okay, so this is 450. All right.
Oh, we're gonna have to redo all of them.
It's fast if you know how to read it.
This is now 450?
Yes.
Oh, yeah, it looks like in between these two. 1, 2, 3, 4, 5, yeah, 550 probably. That
Alright.
is less than
Okay, so here's this one again.
350.
This is 350.
Okay, so wait, for 450 we want to put 550. And now this one
Now I went down.
has 350 again.
I went down.
1, 2, 3, 4, 5. That's about 500. Maybe?
So did you read 500 and 600 incorrectly?
Maybe. I think it's, what would you say, 500? Yeah. Okay.
All right,
That would
now-
actually make way more sense. Like just
Okay.
as a pattern.
Okay, so do you want to try the 550 one?
I think we should try the percent error now.
Okay.
Yeah.
So then what we're going to do is, and we'll put the slope in here. So, slope, so learn, equals slope, y values, which are f squared, then you put a comma, x values. So that's the slope. Okay?
That's what it says down there.
So, yes. So now you can program the slope. So this equals, so our experimental one, now we're going to, instead of typing it in manually for the slope, we're going to click on the slope. All right, so now our experimental mu is this value. I think we got worse.
Yeah. It really did.
It was 6.48 and now it's,
Bad it works.
yes. So we're going to keep this one. How's that?
Okay.
All right, so, and we'll make this just a little bit smaller.
It works.
And if we had time, you know, if this was a, you know, we had next class period, so to speak, you know, we could do things a little more accurately. But at the moment, what we're trying to do is just make it happen, right?
We have
So file,
last
print, does that fit? Do you know what everything is? Does that make sense?
Yep, that's everything.
Okay. And we're going to print to number 1. Print 5, 1 for Ryan, and 1 to whoever, all right? Okay, now, we want to look at the conclusions. Whoa,
Sorry.
all right.
So wait, where would our error come from?
Yeah, that's what we're gonna have to talk about. Save as,
Yes.
desktop,
Number one.
Yes.
desktop. So we're gonna call this tension wave speed, okay? All right. Now, if we look at the lab and the conclusions on the lab, we are now, we didn't do the other string, all right? So we just did one string, okay? So look on the top of, oh, I did a different one last time. I did wave speed squared versus tension.
Are we going to be comparing the first lab that we did today with this? I was going to say, if this is part 2, I don't really get how they are related.
What would wave speed,
Yes.
wave speed, they want wave speed squared versus tension. So, F lambda squared equals 1 over mu times the tension. Oh, that's interesting. Okay, when I wrote this up, we did a slightly different analysis, but it's going to give you exactly the same result. So can you, Annie, make this look at that?
Yes.
Okay.
Got it.
All right.
Oh man, they
So-
missed all of this.
This is us.
Sorry guys. Okay.
This is us today. All right. This is
Okay, perfect.
2009 or something when I wrote it. So we know that wave speed is equal to the square root of
Okay.
tension over mass per unit length. So wave speed squared mass per unit length. So wave speed squared equals 1 over mu times the tension. All right. Now, what we did was we said that wave speed squared is f squared lambda squared. And we graphed f squared equals 1 over mu lambda squared. So, with respect to Bailey in particular, because she's had trouble with this, both of those are absolutely acceptable, yes? In other words, on the first one, the way that it was written on this lab, they would have multiplied frequency times wavelength and gotten wave speed. So they would have added a column called wave speed. And then they would have graphed wave speed squared versus tension, and their slope would have just been 1 over the mass per unit length. What we chose to do was substitute in for wave speed the expression f lambda squared, which is f squared lambda squared, and then we just solve for frequency squared. So it's exactly the same procedure, it's just that the slopes mean something different now. Yes?
Yes.
So our slope is 1 over lambda squared mu. Their slope is just mu. All right, so it's acceptable to do it either way as long as you get tension as your x variable, right? And something to do with what you changed, which was the frequency as your y value, all right? Personally, I think now, since I've been doing this for a few years, I think I like the way we chose to do it today better, just because it truly isolated the variable that was on the y-axis. All right? Good?
Yep.
All right, so now they don't have to see that anymore.
Okay, where are we
They
up
might
to?
want to listen to what we're saying.
This is not the best.
So, yep, you can,
I need like a better way to do this.
all right, you figure something out. They can still hear while you're walking around, all right?
I'll take off my shoes so it's not.
All right, let's see what we want to do. Okay, so let's
Does that hold
do.
it? Miss Colwell, would you mind if I lightly place this in between the tuning
Fine,
forks?
that's fine, we're gonna do a demonstration with it in just a minute, but that's okay, all right?
Ah. No, oh man.
Just put it in the middle and try and.
It works.
Yeah, center of mass, God bless us, all right. All
God
right,
bless
so
America.
actually, at this point, I'm throwing these ratios away, they're meaningless.